Welcome, everyone. Let's give it a second. Welcome to the Safe and Sound Awards. My name is Gayla Pulling. I'm your president-elect and your moderator for today's awards session. As everyone comes on here, we just wanted to point out that closed captioning is available for the presentation and should be showing up on your Zoom screens. For the closed captioning on the bottom there, you can turn that on and off at the bottom toolbar of Zoom. And depending on your version of Zoom, this might look a little different, either live transcript button or more button, depending on the version that you're using. But please adjust the closed captioning to your needs. It is my distinct pleasure today to introduce Dennis Driscoll, who's the president and principal consultant of Driscoll Acoustics, LLC. We know Dennis Driscoll very well. He's been an active member of NHCA since 1985, serving 8 years on the NHCA Council, including president of the association from 1997 to 98. Dennis has over 40 years of experience in engineering, noise control, and hearing conservation programs. I'm going to turn it over to him to kick off the Safe and Sound Awards. Thank you.
Thanks, Gayla. And good afternoon, everyone. I want you to know I miss you, but I look forward to next year when I can see you and let you buy me a drink in Albuquerque. With that said, on to the business at hand. It was 14 years ago when the National Institute for Occupational Safety and Health partnered with the National Hearing Conservation Association to create an award for excellence in hearing loss prevention. And this award is called the Safe and Sound Award. Then in 2018, the partnership extended to include the Council for Accreditation in Occupational Hearing Conservation. I need to click on my screen here. The objectives of the award is to recognize organizations that document measurable achievements in hearing loss prevention and to obtain and disseminate that information on their real-world successes. The awards facilitate the sharing of leading edge best practices to improve the workplace. The Safe and Sound Award winners are recognized not only for their documented results, but also for their leadership in this profession. Health and safety professionals worldwide use the published success stories as real life, high profile examples. Safe and Sound Awards are presented for excellence and innovation. The Excellence Award honors exceptional hearing loss prevention practices. The applicants are evaluated against key performance indicators in a review process designed to evaluate hearing loss prevention programs in the workplace. The Innovation Award recognizes individuals, organizations, or business entities with any industrial sector for innovation advances in the prevention of occupational noise-induced hearing loss. My screen froze up, sorry. Potential candidates for either award may be self-nominated or put forward by individuals outside of the candidate organization or company. If you have a customer or if your facility that you work at is a good candidate, please visit the SafeinSound.US website and get the details with regard to how to file an application. The key deadlines to keep in mind here is June 8th, 2021 is for nominations by third parties, and the completed applications for self-nomination by July 15th of 2021. The Safe and Sound Committee experts are shown here, which are all independent experts. They're active members of NHCA. So if you have any questions with regard to the award or the nomination process, please feel free to reach out to any one of us for more detailed information. I'm pleased to announce the 2021 Safe and Sound Award for Innovation in Hearing Loss Prevention is presented to the Boeing Company, Vertical Lift AH-64 Apache helicopter site in Mesa, Arizona. Now, before I introduce Jason DeStories with Boeing to accept the award, I want to add a few comments here. In my 40 years of helping companies with noise control, some of the best success stories come from the dedicated work of a key individual or a team, small team committed to finding solutions to mitigating some high noise issues. Boeing Mesa is a great example. I had the pleasure and opportunity to work with members of the industrial hygiene group and engineers at Boeing. During my noise control evaluation, I saw their Hush Kit application that you're going to hear about shortly, which I thought was a great innovative approach to one of their more significant noise problems. The major challenge in aerospace is that many noise control applications really must be temporary solutions. Solutions that can be quickly applied, used when necessary, removed from the workpiece or the application that you're looking at, and reused on the next airframe. But I'll let Jason describe the Hush Kit that they developed at Boeing. So to accept the award for the innovation, Safe and Sound is the vertical lift team for the AH-64 Apache helicopter. Jason DeStories will accept the award on behalf of Boeing. Jason has been an engineer for Boeing Research and Technology in the Manufacturing Research and Development Group since 2011. This group is chartered to perform core research and development in manufacturing realm, as well as production support. They focus on development of emerging technologies, beta testing, and implementing applicable technologies in production. Jason's focus is in manufacturing for process improvement related activities. So with that, I will turn it over to Jason.
Thank you, Dennis. It's a pleasure to accept the award for the Boeing Company. And we would like to thank the Safe and Sound organization for hosting this, as well as thank you to you, Dennis, for highlighting this award and making it known to us that we could share this innovation with others. All right, as long as everyone can see my screen, I'll roll into it with our company organization and profile. So we are Boeing at the Mesa, Arizona site. Our core competency is the assembly, integration, and testing of rotorcraft. Now that is specifically the AH-64E Apache helicopter, combat proven with a combination of performance and technology. We build all the Apaches that are supplied to the United States as well as other allied countries across the world. The Boeing Mesa facility, fun fact, opened in 1982. It used to be Hughes Helicopters. 2 years later, it was bought by McDonnell Douglas in 1984, and then Boeing acquired McDonnell Douglas in 1997. So there's a deep history and legacy here at these sites, and a platform that has survived all three of those companies. We have about approximately 4,000 employees and 300 contractors, 2 million square feet of desert, a lot of flat, dry ground, 41 buildings, and 348 site acres. And Dennis pointed out the small team of individuals. This was really the folks that made this all come together. This was a very complex problem in the fact that it reached across many different organizations and different accounting fields. And so there's myself from the manufacturing research and development team. There's Talmadge Ryan, who was one of the repair mod technicians, who was the safety champion, and which we'll talk a little more about later. Israel Lamone, who is our MR&D technician, who helped us build and bring these out to the customer. Stu Lange, who is the production flight test manager, who is the management support behind this project. Jeff Meath, EH&S senior manager, and Parveen Wallam, who is listening with me, and other team members. Eric Knudsen was the IE that helped us coordinate a lot of the ordering efforts. Chris Allen, another tech, and Dylan Barber, who are two other technicians that we use their input to influence the design. With that all being said, let's dive into the problem. So the technical problem, the background overview. The Apache Environmental Control System, ECS, we'll use for short, is technically just an air conditioning system used to keep electronics in cabin cooled. Now, historically, the older versions of the Apache never had this system in place. This hasn't been an issue, but as of the last 10 years, the Block D and E programs, there's been more functional requirements for keeping cabin cooled and electronics cooled. And so what I like to point out are those two chickmunk cheeks on the side of the Apache. They're housing a lot of the electronics, and they have actually air conditioning in them to actually manage the thermal loads. And so similar to anyone who has an air conditioning at their house, the large condensing units that you see on the side of the house or on top of the house generally have a large diameter fan, and they can spin slowly and move a high volume of air to keep that condenser at the cooler temperature. Unfortunately, on this platform, size and weight and all those things are constrained. And so the engineers that were given the task to provide a thermal cooling for the Apache were not constrained in the sense of sound and trying to keep this quiet. So they were constrained in the sense of how small of a fan can I fit in this area to move as much airflow over this condenser to achieve my highest technical performance possible. So on the back side of those chickmunk cheeks, you have an outlet and an inlet. And on those two outlets, for each outlet, you have two of these small ducted fans. And because they're so small, you have to run them at extremely high RPMs to achieve that airflow rate over that condenser. And that's what leads us to the noise that's being generated. And so just more pictures of the overview of the problem. From the factory on the bottom left, you'll see the environment. There are multiple locations where this ECS is run, and that's during any electronic testing of the aircraft. So it'll be in the factory on the main assembly line with the other 20 Apaches, and they'll be running the ECS on the last 2 or 3 Apaches, in which case that noise is carrying over the entire factory. The middle picture shows the outlet, and one on the right shows the inlet. And imagine the ducted fan being kind of right near those outlet areas. And so you still get quite a bit of noise coming from the inlet, even though it is drawing the air in. And that noise source is a high pitched sound, creating about over 100 decibels at the source near it. There is no standing next to this without hearing protection whatsoever. There have historically been engineering controls that solve this, not at the Mesa site, but this was highlighted by a lot of technicians that traveled to international customers. That international customers found this to be such an issue that they actually developed Army equipment that so that they could operate and test the Apaches in their hangars without disturbing personnel. And you can see them, they're large, military grade welded components, height adjustable. They almost look like wheel jacks on all 4 legs that you can adjust the different configurations of the aircraft. And again, this was looked at back in 1998, but at that time, the controls just were not economically feasible. The sets that we did find that were commercially available through one of the depots, they were quoting $58,000 per set, and so that has been on our radar for a long time. But unfortunately, with problems like these in a large company, as usual, the thing that's on fire gets the budget, and to address this at the time was, well, hearing protection's relatively inexpensive, require ear plugs and have controls in place that you must wear hearing protection when working around these. That still it was not an engineering control that was put in place, and it still emitted quite a bit of noise that disturbed the entire factory. But in 2012, for the Boeing company, improving workplace safety became a top priority. And at that time, the Safety Champion program was launched. And the Safety Champion program essentially would have a rotational position that would grab people from all different angles of the organization, whether it was a technician on the floor or you name it, but they would rotate them through these programs. And that Safety Champion at that time, for 6 months, he would be focused on solely providing safety solutions across the site. And at the time, Talmadge Ryan was the person that was selected as the Safety Champion, and he works out in the flight test area. And because of that, he knew that the noise suppression was one of the things that he really wanted to see be addressed. And so he came into our lab one day saying, "Hey, is there any way we can do something about this? Anything? There's been a lot of talk and a lot of big solutions, but let's see what we can do in this short period of time in 6 months." And so that being said, when he got MRD involved, we went out there and we tried to define the situation and figure out what was going on. What we found is that yes, external customer solutions existed, but due to the price, it's just not economically viable. So we did some quick research as to that surely there must be sound suppression for noise solutions out in the market. Sure enough, there's stuff called like these zombie boxes, which you can wrap around your generator, that have sound absorbing panels on them. And so we took that idea and our innovation prototype, fail fast, iterate methodology that we apply to a lot of our projects, and we developed just a box. Our lab looks a little bit like the Mythbusters lab. So we just have materials on hand. So we built a box that matched the dimensions of the outlet on that ECS. We put some sound absorbent foam on the inside, some PVC pipe, and zip tied some sound absorbent foam to those, just a proof of concept. Let's just see how viable this solution is. So this kind of takes us through our methodology, see what exists, build a prototype, testing a prototype. And I really want to highlight this picture when we tested this prototype, because there's Talmadge in his safety champion vest, the bright green vest that signifies who they are on site. And we built that box and we literally rolled it up to the ECS just on a rolling chair. And at that time, I think most people were pretty skeptical that this would do anything. And I remember when him and I first covered up that outlet of the ECS and how much the sound dropped, you could stand there and have a conversation. And we both we knew it. This is definitely going to be a solution. So we took that feedback and I built the design in CAD. We tried to account for things to future-proof it, such as height adjustability. Not all Apaches rolling down the line are in the same configuration, depending on their weight, whether they're fueled or unfueled. And so we try to make it so it's height adjustable, that it could swivel and match the configuration for whatever Apache that may be going through the line at that time. Put things on there such a small footprint and try to keep all the things that we're aware that the customer is important to the customer that we want to bring into the final design. And so we take that design, we brought it out to the floor and we tested it. And to a lot of people's surprise, it worked extremely well. And so we moved forward with a final design, in which case we built approximately 10 sets. And for each set, there's 4 of these. And we're expecting there to be more. But one of the things that we had to keep in mind was that the money had to stay underneath the capital threshold. So we're designing this around certain budgetary constraints to try to make this so we could scale it without running into the capital expenditure issues that most large companies are held against. So you'll see that we took a simple a welded polypropylene enclosure that we worked with a local vendor nearby that could make those relatively inexpensively with all the holes. We put swivel bearings that attaches to. Sound absorbing foam is lined on the inside. The PVC pipes were simply there to hold that pipe insulation to try to prevent, just to kind of create some baffles to try to bring the sound so it didn't have a direct path outward. They're height adjustable, and the steel plate was built in as the ballast. That was one of the important things because that outlet of the ECS is pretty strong. So we needed something that would actually, once you lock those wheels in place, would hold in place while it was there. On the intake side, it wasn't so much of a concern since it was kind of sucking it to the aircraft. Noise reduction summary. The overall noise reduction ranged from 5 decibels to 12 decibels. Now, one of the things that as an engineer, I wanted to convert that into something that made more sense to our management team as we presented to them, because if I walked up to somebody and said, yeah, we reduced it 12 dBA, they wouldn't grasp how much that was actually reduced. Whereas if you calculate that in reduction of amplitude, it ranges anywhere from 37% to 72%. And these noise measurements were validated by a third party, Apex Associates in Acoustics. And this is the data. I'm sure there's more people on here that are interested in what this data looks like from an acoustic level. I think one of the things to point out is this, the attenuation at this peak moment was completely attenuated when the hush kit was put in place. And I'm not sure which was the frequency that you'll hear it in the video. There's a high pitch frequency that everyone really complained about. We believe that may have been the point right there. There were other noise profiles that were not reduced, such as the compressor, which is located about 8 feet forward of the fans, but the majority of the noise that was captured was from the ECS fans. And then a second one, I believe this one was on the I think this was on the pedestrian walkway, and showing that the noise reduction, and again, that peak amplitude anywhere from about 82 to 68 in that particular frequency. And we're going to play a video, and hopefully everyone has their volume up. We'll see how it goes. Very good. Hoping that sound came across well for everybody. You can see relatively simple to implement, and when they're not being used, the small footprint allows them to be kind of stowed out of the way. So next steps, build additional hush kits. We currently have quite a few orders for more of those. And again, we're supporting multiple customers. The color money is different, whether it's final assembly or a flight test or delivery center. And so we're coordinating a lot with the IEs and the teams to get those parts to show up, because they're under the capital threshold. As long as the parts get here, we're able to provide a solution. Also, we want to extend customer awareness of the innovation to our international customers. Leverage the award to communicate to other teams within Boeing for future innovations. For example, we shared this with our Philadelphia counterpart, who was the Chinook, who actually runs a similar system on the aircraft, and they're looking for noise reduction solutions. So we shared this with them, and inspire other employees to become engaged and take action. I think this problem historically was a very bureaucratic problem, in the fact that because it was a capital expenditure and it was a different priority on everybody's their roadmap, it didn't get addressed. And it wasn't until we were able to get that safety champion program in here, and innovation to get a solution on the floor. So some of the lesson learned: working together and collaborating can lead to cost-effective innovations. And again, I like to point out that team and the team members in the very beginning there is everyone came from different organizations to really make this happen. There's customers that we don't necessarily support, but they're out on the flight line, and they have guys that order parts. And we said, if you make these parts show up at our doorstep, because technically from our organization, we weren't allowed to order for them. So if they made these parts show up, we could build additional units and provide them out there. And again, there was nothing but collaboration across the board from a lot of those team members on there. One employee's idea can lead to a significant improvement. I like to point that to the safety champion program that Boeing created. That really allows the technician on the floor, or the person who typically doesn't get to address, take the time to address the safety concerns that we know are there, or the annoying hearing issues that we may know are in the area, that they can actually bring this up and do something about them. And the third point: innovation is needed when the solution is not obvious or costly. I recognized that going into this project, that it was plagued with hurdles of being too costly to implement a solution. So we actually designed around the constraint of a certain budget requirement to try to keep it underneath the capital threshold, so that we could provide the solution to our customers. And team-based business initiatives are encouraged for employee involvement teams. And this is something I'm sure other companies do, but Boeing does TBBIs, in which case we showcase certain things like this to share the awareness of these innovations across the other groups. Significance of the award to Boeing: the award will raise awareness to the importance of engineering solutions to control noise. And the award will create recognition within Boeing and other stakeholders. Again, this is going in alignment with Boeing's safety initiative on providing engineering solutions to control noise, which is preventable. Boeing will continue to innovate to improve workplace safety. In the future hearing protection standard for the Boeing company, one of the Boeing's safety standards includes the hearing protection standard, HPS. The ultimate goal of HPS is to reduce the risk of hearing loss, which is mandatory hearing protection for specific tasks. New equipment must be at 80 decibels or lower, employees hearing fit evaluation, and as well as creating an internal team to explore engineering controls. And this is something that's relatively new that they're standing up. They're putting together a tiger team, if you want to call it, within the Mesa site of people that are experts across the organization in terms of MR&D, being able to provide solutions, facilities, who's aware of certain high noise areas, and making a list of all these high noise areas, and can we implement engineering controls to address these? And I believe that's the end of the presentation. If anyone wants to reach out to me for any technical questions or engineering questions, there's my contact information, or any administrative questions or EHS safety questions, can reach Jeffrey Meath, located there. All right, and with that, I'll open it up to questions.
Hi, this is Jim Jerome, and I have to congratulate you on something so beautifully simple to accomplish and with such great impact. My question is, after you mounted both of these noise reduction items on the helicopters, what was the overall effect in the entire work area as far as sound levels? Were they to the point where some people in the areas did not have to wear hearing protectors, or is it just mandatory that hearing protectors are worn in the facility, regardless of where you're at?
I believe we still have mandatory hearing protection in place for the areas that work directly around the ECS. However, after we implemented them, like for example, in the final assembly line, we had groups, we have a wire shop maybe 50 feet, 100 feet next to the assembly line. We had groups reaching out to us and just thanking us because it was something that it wasn't above that threshold, but that high pitch whine drone going across the factory was just always present. But after these were implemented, that completely cut that out.
Thank you.
And I think I saw a question in the chat for how durable are the materials. It is a polyurethane-based sound-absorbing foam. One of the recommendations that we asked is to have them not exterior or exposed to UV, and that we also made them so that they were replaceable. It is something on our radar to keep an eye on them over the years, especially in Arizona. Sometimes they may leave the hangar door open and may get exposed to UV, and that they can get kind of dusty or crumbly on that shipping foam.
Jason, do you have an idea of the estimated cost?
Yeah, the estimated cost per ship set was about $2,400, which works out to about $600 per each individual hush kit there.
That's fantastic.
Like
another question I see is,
oh, sorry.
Sorry,
Karen
are these
Turner is raising her hand for a question.
What does a helicopter cost?
I don't believe I know.
34 million.
I saw another question. Are these are they sometimes forgot to be used by the workers? The answer, from my understanding, is absolutely not. If there's something in place to keep these things quiet, they'll even have people. If somebody did forget, that's working in the immediate area with hearing protection, somebody from the wire shop or next door will actually come over there, grab those, and push them on place, because it brings a level of quietness to the factory that a lot of people like.
Jason, can people use the video you have in any of their training sessions? Because it's a very dramatic effect that somebody just listening to it can really gauge the benefit of it.
Yeah, I believe if it's public and it's posted on the webpage, yes, they're welcome to use that. But we can confirm somebody on our end if anyone needs confirmation of sharing that.
Oh, hi, this is Thais. Whenever the materials that the companies submit with their nomination is under the agreement that we can share those materials. So yeah, and the whole video will be available, not only the noise control part will be available in the Safe and Sound website next week.
Perfect.
Thank you.
Well, I guess I'll wrap it up here and say, I love those dramatic drops in noise that really grab the attention of people. I think it really helps to motivate them to continue with their noise control efforts. The big advantage at the Boeing Mesa facility was the noise level can be relatively quiet a lot of times, and then you have these dramatic sudden increases in noise that are really dominate the whole area or even a whole building. So when you drop the noise level by 10 dB or more, as we know subjectively, that's half as loud to the listener. That's very important for people to, again, get motivated to carry forward with additional noise control measures to keep chipping away at their noise levels. So in conclusion, I want to thank our expert committee, NHCA, and the KAC leadership, and the candidates and those who submitted nominations. As I mentioned earlier, if you work for a company or have a client that you think would be a good applicant, please put them forward. Congratulations to our 2021 Safe and Sound winner, Boeing Mesa facility, and keep up the good work. Now we're going to head into our network opportunity with the sponsor session, which starts right after this session. So please access that, I think, through the Learning Center. If I'm incorrect about that, NHCA will let me know.
Nope, you got it. And the Zoom link is also in the chat as well for the next session.
Great. Well done.
Thank you.
Great. Thank you, guys.